Hello, guys. Congratulations for taking the AMC 10A from 2021. Right? I'm sure it was challenging, but you should feel proud that you did it, and I hope you somewhat enjoyed the experience. Um, right? This is Mr. O'Brien, and I'm going to be going over the problems. I'm going to be breaking it up into different sections. So I'll start with I might do 1 through 10 in my first video, and then maybe I don't know. I'll see how I break it up from there, but. Okay, so I just wanted to give you guys some solutions to some of these problems. And I also encourage you to give me solutions. If you have something else that I didn't think of, or if I do it a harder way, please let me know. I love to see new methods, right? All right, number one, what is the value of 2 squared minus 2 minus 3 squared minus 3 plus 4 squared minus 4? All right, let me get my pen here. So 2 squared minus 2 is 2 minus 9 minus 3 is 6 plus 16 minus 4 is 12. 2 minus 6 is negative 4. Negative 4 plus 12 is 8. So our answer should be D8. Easy schmeezy, right? Okay, number 2. Portia's high school has 3 times as many students as Lara's high school. The two high schools have a total of 2,600 students. How many students does Portia's high school have? Okay, so I'm going to use a variable. I'm going to say P. Whoops, that's not good. I'm going to use the letter P to represent the number of students in Portia's high school, right? And I'm going to use L to represent the number of students in Lara's high school. Portia's high school has 3 times as many students as Lara's high school. The two high schools have a total of 2,600 students. How many students does Portia's? Okay, so P plus L equals 2,600, right? Remember, P equals 3L. 3L plus L equals 3,600. 4L equals 3,600, right? L equals 900, right? So that tells us that right? 20. Oh, sorry, I made a mistake here. Sorry, that's supposed to be 2,600. I don't know how I did that. Sorry. Somehow I turned a 2 into a 3. So 2,600. 4L equals 2,600, right? So remember that 2,600 is obviously 26 times 100. So 4L equals 26 times 100, and 100 divided by 4 is 25. So L equals 26 times 25, right? Remember, ultimately, we want to know how many students Portia's school has, right? And she has 3 times as many. So we want 3 times 25 times 26. And 3 times 25 is 75. So 75 times 26, which if we do that, we get 1950. So we get answer choice C. Okay? So again, number 2, not supposed to be too crazy. Number 3, oops, I got to move this bar up a little bit. Sorry. The sum of two natural numbers. So remember, natural numbers are like positive integers, right? The sum of two natural numbers is 17,402. One of the two numbers is divisible by 10. If the units digit of that number is erased, the other number is obtained. What is the difference of these two numbers? Okay. So we have two numbers that when we add them, we get 17,402. One of them has to end in a 0, and the other one is basically that number take away the 0. Right? So we have some number A and we have some number B, such that A is basically, or A is essentially B with a 0 at the end of it, right? But how do you take a number and add a 0 to the end of it? Basically, you just multiply it by 10, right? So, right, if I want to turn 126 into 1,260, I have to multiply by 10, right? So it basically just means A equals 10B, right? A is equal to 10B, and A plus B is 17,402, right? But remember, A is 10B, so 10B plus B is 17,402. 11b is 17,402, right? Divide by 11, and I got, when I did that, I got 1582. 1582, right? So that means, so if B is 1582, that means that A is 15820, right? And the question wants the difference between them. So in other words, it wants 15820 minus 1582, and that comes out to 14,238. 14,238, which will be our answer. So that's choice D. All right. Okay. So maybe the wording was a little tricky, but the question itself isn't really that bad, right? Number 4, a cart rolls down a hill traveling 5 inches the first second and accelerating so that during each successive 1 second time interval, it travels 7 inches more than during the previous 1 second interval. The cart takes 30 seconds to reach the bottom of the hill. How far does it travel? So this is basically an arithmetic sequence because we start with 5. All right, maybe I should use a different color. We start with 5. Oh, where's my pen? Here. 5 plus, right? And each time it's increasing by 7 more than the previous, right? So it's going to be 5 plus 7, and then it's going to be plus 5 plus 7 plus 7. So we're looking at essentially an arithmetic series, right? Arithmetic series, and we're going up to 30. But remember, like in the first second, it didn't increase by 7 yet. So that means during the 30th, it's going to be 5 plus 29 times 7, right? So we're summing 5 plus 5 plus 1 times 7 plus 5 times 2 times 7, 5 plus 2 times 7 plus 5 plus 3 times 7, dot, 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 plus 5 plus 29 times 7. So we're adding 30 terms in total, and clearly each one of them has a 5 in it, right? So we definitely want to start off with 30 times 5, right? And then we're adding a lot of 7s. The question is how many 7s? Well, we're adding 1 plus 2 plus 3 plus 4 plus 5, dot, 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 up to 29. So we're adding 7 times the sum from 1 to 29. And, you should know the formula that says that the sum from 1 up to some integer n is equal to n plus 1 divided by 2, right? That's something that you should know going into an AMC exam. It's a very famous kind of little formula. So since this case it's 29, it's going to be 29 times 30 over 2, right? That's going to become 15. So I did all the math here and I got 3195. 3195, which is choice D, right? So the answer for number 4 is D, 3,195. Okay? All right. Number 5, the quiz scores of a class with more than 12 students have a mean of 8. Remember, mean is like average, right? The mean of a collection of 12 of these quiz scores is 14. What is the mean of the remaining quiz scores in terms of K? Okay. So, here's how I thought about this. So let's think about the mean of the entire class, right? Now, how would I calculate the mean score of the entire class? Well, I would take the sum of the K scores, which I'm going to call S sub K. I would divide by K, and that should give me 8, right? Because the average of the K scores is 8. But remember, this basically means that S sub K equals 8K, right? Whoop, that's not a good K. So now, what about for the 12, though? Because we have a mean of 12 of these scores is 14. So we're going to do S sub 12 divided by 12 equals 14. Or S sub 12 equals 12 times 14, which is 168, right? So S sub 12 is 168. Now, we want the mean of the rest of the scores, right? So we basically have K tests lined up. We took 12 of them away and realized that they had an average of 14. So now we're left with K minus 12, right? We want to find S sub K minus 12 divided by K minus 12, right? That's what we want to find. Well, think about it. The sum of K minus 12 tests would be equal to the sum of the K tests minus the sum of the 12 tests. That would leave us with the sum of those remaining K minus 12 tests. So this is basically SK minus S12 over K minus 12, right? But what's SK? SK is 8K, right? S12 is 168, and that's over K minus 12. Does any of the answer choices look like that? Choice B, right? So B is our answer. Okay. You might have tried this by maybe picking a number for K, which I guess could work. That maybe I didn't try that, but maybe trying to pick a number for K could work. Maybe something that maybe 20 or something, a nice number, 15. Yeah, that's a good SAT strategy to pick a number, right? Especially if it seems like the number itself doesn't matter, right? Remember, it didn't ask us to solve for K. It asked us to find the mean in terms of K, where K can change, right? So you can pick a number for K. Number 6, Chantal and Jean start hiking from a trailhead toward a fire tower. Jean is wearing a heavy backpack and walks slower. Chantal starts walking at 4 miles per hour. Halfway to the tower, the trail becomes really steep and Chantal slows down to 2 miles per hour. After reaching the tower, she immediately turns around and descends the steep part of the trail at 3 miles per hour. She meets Jean at the halfway point. What was Jean's average speed in miles per hour until they meet? Okay. So, all right, this is a lot of information, right? This is a very wordy problem. Let's draw a picture. Maybe that'll help us, right? So remember, they start hiking just sort of maybe on a flat ground, and then all of a sudden they're going up a hill and it's getting a lot steeper, right? And it says halfway to the tower, the trail becomes really steep. So this is the halfway point. So if I call this distance D, this distance would also be D, right? These are equal. Okay. So let's see what it says. It says Chantal starts walking at 4 miles per hour. Halfway to the tower, the trail becomes really steep, and Chantal slows down to 2 miles per hour. After reaching the tower, she immediately turns around and descends the steep part of the trail at 3 miles per hour. Now, we want average speed, right? Now, average speed is calculated by finding total distance traveled divided by the total time, right? So we need to find how far she traveled, right? Well, think about it. She's going to travel D miles to get to the halfway point. Then she's going to go up the hill D miles, and then she's going to go back down the hill D miles. So in total, Jean will travel 3D miles. I'm sorry. That's that is Chantal. Sorry, my bad. So by that point, Jean only travels D miles. So right, but we need to find the total time that elapsed. Well, let's think about it. So Chantal traveled the D distance in 4 miles per hour, right? D miles at 4 miles per hour, right? So think about it. If you travel 100 miles at 50 miles per hour, how fast did you go? How long did it take you? It took you 2 hours because you do 100 divided by 50. Same thing here. She travels D miles at 4 miles per hour. That means her time would be D divided by 4 hours. Right? Does that make sense? Like, right? Or you could just think about the units, like D miles, right? Oh, I'm sorry. Divided by 4 miles per hour. Notice how if you divide this, miles will cancel out and hours moves up to the top, right? So a lot of times that's how sometimes I struggle a little bit with like, should I divide or multiply? I use the units to help me figure it out, right? That's always a good trick. Right? Okay, so that tells you, so she went D over 4. And then for the second part, going up the hill, she only went 2 miles per hour. So now she went D over 2 hours, right? And then for the last part, she did 3 miles per hour. So it's going to be D over 3. And then by that point, that's when she meets Jean. So Jean has been walking for that whole time. So this should give us Jean's average speed, right? Notice how we can cancel out D's, leaving ones in every space. So we need 1 over 1/4 plus 1/2 plus 1/3, right? Which I'm hoping you guys would know how to simplify that. But when you do simplify that, you end up getting 12 over 13, right? Oops. So basically what you could do is just multiply everything by 12, like multiply each piece by 12, and then that'll get rid of the fractions, and then it just adds up. The bottom just adds up to 13. So, all right. So the answer is A, 12 over 13. Okay. So the answer for number 6 is A, 12 over 13. All right, number 7. Oh, I like this one's fun. I like these kinds of problems. They can be very, remember I run the logic puzzle club, so I love this type of stuff. So it says Tom has a collection of 13 snakes, 4 of which are purple and 5 of which are happy. He observes that all of his happy snakes can add. None of his purple snakes can subtract, and all of his snakes that can't subtract also can't add. Which of the following conclusions can be drawn, right? Okay. I don't think the numbers matter. Other than to possibly let you know that the purple and happy categories don't need to intersect because they don't add up to 13. So, right? So I think it's just to let you know that like there are like there's other categories other than purple and happy, right? So he observes that all of his happy snakes can. Okay, so if a snake is happy, it can add, right? None of his purple snakes can subtract. So if a snake is purple, it cannot subtract, right? But that doesn't imply that any snake that can't subtract must be purple, right? That's not the same thing. And then the third thing says all of his snakes that can't subtract also can't add. So if none of the purple snakes can subtract, right? All snakes can't subtract, can't add. So the purple snakes can't add or subtract, right? So we can get rid of some answer choices, right? We can get rid of A. A doesn't make any sense, right? Oops. A is not possible because how could the purple snakes can't add if they can't subtract, right? Now one thing that's kind of useful to know is that okay, so if you look at the third condition, right, it says all of his snakes that can't subtract also can't add. So another way to think of that is to say can't subtract implies can't add, right? If a snake cannot subtract, then that snake cannot add, right? Right, so that's called the conditional statement, right? You have if P then Q, right? But one thing you know is that if you have a statement like if P then Q, you also have what's called its contrapositive, which happens by basically switching them and negating both of them. So what's the switching and negating of can't add implies can't subtract, or sorry, can't subtract implies can't add, would be can add implies can subtract. Right? Which makes sense because if you can't subtract, you can't add. So therefore, if you can add, right, then you can't be here, which means you can't be here. So they must be able to subtract, right? So one thing we can now tell is that remember all of his happy snakes can add. Any snake that can add can subtract. So we know that happy snakes can subtract, right? So actually that means we can get rid of E, right? E doesn't make sense. But remember, we now know happy snakes can subtract, right? Happy snakes can subtract. And we know purple snakes cannot subtract, right? So that means happy snakes cannot be purple because because all of his happy snakes can add means all of his happy snakes can subtract. None of his purple snakes can subtract. So therefore, none of the happy snakes can be purple, right? So that means that D has to be the correct answer, right? Um, Purple snakes are happy. Well, purple snakes can't subtract, and happy snakes can subtract. So that can't be possible either. So C can't work. Sorry, B can't work. Snakes that can add are purple. Well, purple snakes can't subtract, and can't subtract means you can't add. So C is also wrong. So, right, so that means that D has to be the correct answer. All right, correct answer for 7D, happy snakes are not purple. Number 8, when a student multiplied the number 66 by the repeating decimal, 1.AB, AB, AB, right, forever, he did not notice the notation and just multiplied 66 times 1.AB. Later, he found that his answer is 0.5 less than the correct answer. What is the two-digit integer AB? Okay, so one thing that you need to know. Well, okay. So how do you get something like point? Oops, sorry, went too far. How do you get something like point AB? Right? Like how do you get this? Right? Oh come on, why is it going nuts? Right? How do you get that? Well, how do you get a point AB? Well, you get it by taking the number AB, the number that's formed by the digits A and B, and dividing it by 100, right? But it's not just going to be AB divided by 100, right? It's going to be 10A plus B divided by 100, right? For example, how do you get 0.52? You get 0.52 by doing 52 divided by 100, right? Which is 50 plus 2 over 100, right? 5 times 10 plus 2 over 100. So, okay, that's how you get it. So this number here would be obtained by doing 1 plus 10A plus B over 100, right? And he multiplies this by 66, right? Times 66. Now, how would we get this number? How would we get 1.AB repeating forever? Well, the way you get repeating decimals is by dividing by nines, right? Anytime you divide by 9, you get a repeating thing. Like, for example, if you do 2 over 9, that's 0.2 repeating, right? 4 over 9, 0.4 repeating. Well, how would I get 0.21 repeating? How would I get that? I get it by doing 21 over 99, right? Okay, so by taking a two-digit number and dividing it by 99, you get the repeating decimal of that two-digit number, right? So, whoops, I did not mean to do that. Okay, so how am I going to get that? Sorry, okay, so he found that his answer of 0.5 less than the correct. Okay, so the correct answer is supposed to be this, right? So we're supposed to be taking 66 and multiplying it by 1 plus 10A plus B over 99, right? 99. But this answer this is the mistake answer, right? Is is 0.5 less than what the correct answer was supposed to be. So basically, we just have to solve this. Now, you might be thinking, how are we going to solve for two different variables, A and B? Remember, we don't need to solve for two different variables, A and B. We just need the expression 10A plus B, right? So we can just call X 10A plus B and solve for X, right? And once we have that, that's our answer, because they just want the two-digit number AB, right? So let's see what happens here. So we're going to get 66 plus 66x over 100, right? Equals 66 plus 66x over 99 minus 0.5. So we just have to solve that, right? It's a lot of algebra. Basically, like this reduces to what? 66 over 100, 33 over 50, right? And this reduces to 2/3. We can cancel the 66s out, right? So you end up doing 2/3 minus 33/50ths. 2/3 minus 33/50ths x equals 0.5. Whoops. Equals 0.5, right? And when you solve that, you end up getting that x is 75. So the answer is 75e. Okay? So the answer for number 8 is E75. Number 9, what is the least possible value of what is the least possible value of that for real numbers x and y? So least possible value. Okay. So, well, let's expand it and see what happens when we do that. So if we expand this, right, we would get xy squared minus xy, so minus 2xy, right? I'm expanding this part, plus 1 plus x squared plus 2xy plus y squared, right? And we want the smallest possible value for this function for real values of what x and y, right? So no imaginary numbers. So now notice how these will cancel out. So we'll have xy squared plus x squared plus y squared plus 1, right? So now let's just think about this for a second. So we have basically this quantity plus 1, right? But think about it. This is a perfect square, this is a square, this is a square, right? And for squaring real numbers, the lowest value you can possibly get is 0. Right? The lowest possible square of a real number is 0. You can't get negative because you're not dealing with imaginary numbers. So if this has minimized at 0 when x and y are both 0 basically, right? Then that means that the minimum value that this function can have would be 1. Right? Does that make sense? Because this has to be greater than or equal to 0. So therefore, the whole thing has to be greater than or equal to 1. So the answer should be D1. This one I thought about way too much. I this is a type of question that you can really. I actually started doing calculus at one point, thinking I should take a derivative and doing all this crazy stuff, but it's not like a question like this. Remember, you're not allowed a calculator. It's assumed you haven't learned calculus yet, so and it's a 2-variable function, so there has to be some trick to solve it, right? So the answer is 1. All right, number 10. Which of the following is oh yeah, okay, I remember this one. This one is what I would call like a classic. I hate to use the word trick question, but kind of. Maybe not a trick question, but like there's a trick to solve it in a way that doesn't make you go insane, right? Because you are not supposed to just sit there and calculate all this stuff out and calculate each answer choice. It would take forever. You're not supposed to have a calculator, so right? All right, so this is okay. When I look at this problem, the first thing that comes to my mind is like I see a lot of like I notice that all the powers are even, right? So I'm seeing a bunch of sums of squares, right? We don't really have a formula for a sum of perfect squares, right? But we definitely have a formula for a difference of perfect squares, right? We know that whoops, I don't know why the first thing I write is always messed up. We know that a squared minus b squared equals a plus b times a minus b, right? So we know that a squared minus b squared equals a plus b over a minus b. Well, so what? I don't see any minuses here, so why am I telling you this? Well, what if I looked at this, right? What if I know that 2 squared minus 3 squared equals 2 plus 3 times 2 minus 3, right? But doesn't that mean that 2 plus 3 equals 2 squared minus 3 squared over 2 minus 3? right? So I can replace the first term with 2 squared minus 3 squared over 2 minus 3, right? That's the first one. So what about the second one? Well, the second one, well, how could I get that? What if I did 2 to the 4 minus 3 to the 4 equals, sorry, 3 to the 4 equals 2 plus, sorry, 2 squared plus 3 squared times 2 squared minus 3 squared, right? So that means that 2 squared plus 3 squared is 2 to the 4 minus 3 to the 4 over 2 squared minus 3 squared. So 2 to the 4 minus 3 to the 4 over 2 squared minus 3 squared. And then you're starting to see a pattern, right? So for 2 to the 4 plus 2 to the 4, 3 to the 4, it's going to be 2 to the 8 minus 3 to the 8 over 2 to the 4 minus 3 to the 4. And as you're doing this, you're noticing that things will cancel out, right? Because we can then look and see, I can do like dot, 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 right? And then do the last one, 64. Well, how do I get 64? I get that by doing 2 to the 128 minus 3 to the 128 over 2 to the 64 minus 3 to the 64, right? That'll give me that. And then notice how like this cancels with this cancels with this will cancel with the next one, right? So notice how the top of the one before cancels with the bottom of the next one. So that means that the top of the one that comes before this will cancel with the bottom of that one, right? So that 264 minus 364 will cancel. So we're just going to be left with 2 to the 128 minus 3 to the 128 over 2 minus 3. But 2 minus 3 is negative 1, which basically takes this and just turns it around. So it becomes 3 to the 1. Oh, sorry, this is supposed to be, yeah. So it ends up becoming 3 to the 128 minus 2 to the 128, which is choice C. So the answer for number 10 is choice C. Yeah, these types of problems, the only reason I'm like good at this now is because I've done so many AMC 10s now. When I was in high school, I did not know how to solve problems like this. These problems I would just spend all my time trying to calculate this stuff. And that's just not what you're supposed to do. Whenever you see something crazy like this, there's always some weird trick, right? Then and it's always like then someone shows you and it's kind of like that aha moment, like, oh, that's what I was supposed to do, right? And some people sometimes you just can't think of it some people when you're in a time crunch on a test, you're not thinking creatively, right? So these types of problems are probably intended to mess you up, right? That's probably what they're meant for. And if they are messing you up, you should just skip it. All right. Okay, so I think I'm going to end this video here. Probably really long. I don't know. My next video, I don't know if I'll do like 11 to 15. Maybe I'll break them up into chunks of 5. Because once you start getting into like 15 and on, then each question can take like several minutes and a lot of room to do the work. So I might just maybe do 11 to 15 in my next video. All right. Okay. Hope this helps you guys, and please let me know if you found some other way to do the problem. Okay, bye.